So this is the OpenLog Artemis. It's a data logger. And these are two different types of temperature sensors. So this guy here is the TMP117, and you can tell that because it says so on the white silk screening. Also, the temperature sensing chip is a little bit isolated from the circuit board. There's two slots cut on either side so that heat in that little area can go up and down with the environment a little bit more. And because this chip is more sensitive and more precise than this chip over here. So this is the TMP102, and there's a chip in the center there. It's also a temperature sensor. So this guy costs about half what that guy does. It's also a little bit less precise, but if you don't need super precise measurements, this guy will do a pretty good job for you. Now, you can daisy chain multiple I2c sensors on an I2c bus. There are some limits on the total length of the bus, but we're going to be daisy chaining a couple here. Now, there are other problems with daisy chaining these two chips specifically, and that's the chip address. So both of these chips have 4 different addresses that they can be assigned to. They start at 48X and they go to 49 and then 4A and 4B. And so by default, both of these chips come with address 48. And so if you plug them both together like this and then plug it into the OpenLog, it will not be able to address these chips because they'll kind of both respond to commands and both try to talk at that same address. So you need to take one of these guys and put it to a different address. So I'm going to show you how to do that on this guy over here. And that also means that you cannot put more than 4 of these particular temperature sensors on the same I2c bus. But there's ways to get multiple I2c buses off of this. We'll talk about that later. All right, so when you have these chips, typically the way they assign the sensor value is there's one pin that you can tie to ground or positive voltage or the SDA or the SCL line, and that will change between one of 4 pre-programmed addresses. So on this SparkFun Breakout board, the way you can change this is with these little pads here. And you might notice that the pad that says 0x48 is highlighted because that's the default. And there's also a connection between that pad and the center pad. And that little tiny connection is connecting that to ground. It basically says, oh, assign this chip address 48. So if you don't want it to have address 48, you need to cut that tiny little connection. And they say using like a razor knife or a hobby knife. You could also use a super thin grinding wheel on a Dremel. You just have to cut that copper trace so that it's gone and not electrically conductive anymore. And then you need to reconnect one of these other 3 setups. So, I'm just going to go to 49 because that's the next available address. And I'm going to do that with soldering. So I'm going to take solder and connect between the center point and the the side that says 049. You just need a tiny little blob of solder between those 2 points. And that's something you could potentially undo. You could have a solder sucker or a solder braid and pull the solder up and then solder a different connection to change the address. But typically, we're going to set the address and then we're just going to write, 49 on the back of this board, and this address, this board will always be address 49. Now, there's also a thing that says LED, and so if you cut the connector on the LED, you can disable the light. So if you don't want your temperature sensor flashing a light or being powered, you can turn off the power to the light. They also have these I2c connectors, which are pull-up resistors, and in some cases, depending on the length of your cable and the number of chips on it, you might want to cut those to change the layout of the pull-up resistors. We'll talk about that later if it becomes an issue. So not necessarily the cleanest solder blob there, but it's connecting those 2 pads. And we just write 49 on this so that I can easily see that this is address 49 without having to decode which of those pads is soldered. All right, so now when we turn this guy on, it's found the temperature TMP117 chip. That's at address 48, which is its default address. And now it's found our temperature TMP102 chip, and its address is 49. So you can see we have 2 of those 4 addresses used. Now, if you are watching my first video, I have configured the inertial measurement unit. It has a built-in thermometer. we're getting one temperature sense from the open log Artemis itself, and then we have the degree C, which is from the TMP117, and then we have the TMP102 degree C, which is from the TMP102 sensor. In the future, I might be changing this string to include the address of the sensor, because I'm planning on having lots and lots of these sensors chained together, and so we'll need probably a way to differentiate which sensor is which. So currently the hardware string just looks like this, as we have the OpenLog Artemis sensor there, then we have this guy, the 102, and it's address 49, and then this drive over here is address 48 by default. And so we could reverse the orientation of these two and they would still keep the same addresses, so the position on this chain doesn't really matter. Okay, so those solder joints were a little bit nicer looking, so I have my 4A and 4B to go with my 4.9. I'm also opening up a generic 4.8. So this guy's just straight out of the factory, it's set to 4.8. So I have all four addresses this chip can do. This is unplugged. You want to make sure there's no power on these guys when you're putting them together. And just remember those little holes, the tiny little holes go to the top of this connector. So we're just going to daisy chain these guys all in a line. And as I said before, the address numbering is not terribly important. If you want to keep it nice and neat, you can do 4.8, 4.9, 4A, 4B. But realistically, the addresses are set on those little solder connections, not by their position in the line. All right, so we have all four of these boards connected, and now we can plug this into power. And we want to check, we have a red light on each of these boards, so they're all getting power. All right, so the first time I plugged all four of these guys in, it didn't work. I'll show you what that looks like. So when you plug this guy in, it checks for the quick devices. You can see right here it says no quick devices detected. And that means that there's a problem, most likely with the address buses, of one of these devices. And how I figured out which one of the four it is I just plugged in one at a time. I kept adding one until it stopped working, and it stopped working on this 4A guy. And so if I don't have the 4A guy plugged in, and I plug the other three in, this guy here detects devices, and it goes through and it says, hey, look, I got 48, 49, and 4B. So those three devices are working correctly. So my suspicion is that perhaps I did not cut the trace far enough, so this guy is still identifying as a 4.8 device. And if it's identifying as a 4.8 device and there's already another 4.8 device on the bus, that can mess up the whole bus. So I'm going to go and I'm going to scratch out that trace a little more and see if that was my problem. All right, I went and examined that, and if you have a multimeter, you can put it on continuity mode and check continuity between the pads, and it was still connected even though I'd scraped on it. So I scraped on it some more, I tested it was not connected now. So I believe this is going to be address 4A at this point. So we will plug that in and test that out. Okay, and now we can see here it has 4.8, 4.9, 4A, and 4B. And we have here the temperature sensor from the IMU unit, as well as 1, 2, 3, 4 TMP 102 degree C temperature readings. And so I'm probably going to add a wire number and address to the string here, maybe even replacing the TMP102 with the wire number and address so that each of these headers will have a unique ID so that we can basically say, okay, I know which sensor is at which depth in the lake. Now, you might notice that these chips can only do 4 addresses, so that means you can't have more than 4 of these chips on a particular I2c bus. However, there's multiplexers where we can have multiple buses daisy chain off each other, so we can get a lot of these guys attached to one data logger.